Dave is Vice President of Strategy at Scitara, and Dave is going to present today with 30 years of products and global account management experience. Worked for Waters, New Genesis, Cambridge Soft, and PerkinElmer, and now working for Scitara. So lots of experience. Really looking forward to hearing what you've got to share, David.
All right. Thanks. Well, thank you very much, and very much appreciate the first speaker and the opportunity to speak with the group here. I'd like to take the opportunity to share a little bit about Scitara and the Scitara Digital Lab Exchange. Takes a bit of a different approach to defining and identifying a solution to the particular challenge of integration in the lab. The role that Scitara plays in the lab is really very focused, and I think you'll see this in the course of our presentation. Scitara Digital Lab Exchange is an integration platform as a service, or an iPaaS technology. We call it iPaaS for science. We're not a typical scientific application. We're not really a data repository. We really are infrastructure, commercial configurable infrastructure. And our goal is to really drive data mobilization, data mobility, and digital decoupling to put the power back into our customers' hands about accessing virtually all of the data in the laboratory ecosystem and making sure it winds up in the right place, wherever that place might be. So we're going to talk a little bit today about the powerful automation orchestration capabilities that are offered here, the kind of conceptual peer-to-peer connectivity that drives data mobility, a focus on commercial and capabilities and compliance. This is a technology that's designed to operate in a regulated environment, and really putting the control back into our customers' hands about accessing those data, getting rid of those data silos, and being able to really advance and accelerate the process of science. So with that, let's get into a few concepts, and of course, we'll make sure there's plenty of time available for ongoing questions. So historically, if you think about the laboratory ecosystem, consisting of multiple types of instruments, software, files, people, and the ability to exchange data across any two endpoints has been available for 30 plus years. This technology has been around for a long time. The challenge is that these integrations tend to be very brittle, very purpose-built, and they're usually driven historically by some of the more larger monolithic applications. And if you look at the point-to-point technology and you think of it in the context of the laboratory ecosystem as a whole, you can see that very rapidly it becomes a mess. And we've had many partners actually come to us that have written out many of these types of integrations and basically said they just don't have the time, the energy, and the patience to continue to maintain these challenges. You'll notice here that there's a lot of different kinds of systems that are out there. There are LIMS systems, e-notebooks that were referenced in the prior conversation. Data lakes were also referenced, and these have become prevalent to the point where, from the Scitara point of view, a data lake is really a peer, if you will, to a LIMS or an e-notebook. Then you have also benchtop systems like balances and pH meters that might not have PCs, streaming data systems like bioreactors. All of these have different methods of communication. And if you want to create an ecosystem that allows them all to exchange data with each other, you really need a different way of thinking about how these different types of equipment, these types of systems are going to exchange data, whether it's a physical person, an instrument, a piece of software. One other comment I mentioned in the first slide, and I'll bring it up here, is that from the Scitara perspective, all of these different endpoints, we call them connected endpoints, they're all peers. They all consume data and they all generate data. And the objective is to allow them and create an environment where these different connected endpoints can freely exchange data or mobilize data at will. based on business rules that our customers define. So in order to do that, it requires, as I mentioned, an infrastructure. As I said, Scitara Digital Lab Exchange is not an application, it's not a repository, it's not a data lake. We are a transaction engine, effectively. And if we do our jobs collectively, if we do our jobs properly along with our customers, we can almost disappear. And that's actually part of the goal, is to enable scientists in the laboratory to do their job, use the systems that they have in the lab space more effectively, more efficiently, and freely move data and exchange data back and forth across all of these different elements. And so in order to do that, we've created an environment where we have a portfolio of commercial connection technologies. Now, these include a combination of what we call branded connection technologies, where we've worked with a partner based on their API and built a seamless connection technology into that platform. Most of the leading e-notebook vendors fall into that space, including the Revity Signals, Benchling, IDBS platforms, LIMS systems such as LabVantage and Viva, to PC-based systems such as Chromeleon, Waters and Power, for example, to benchtop systems, standalone systems that don't have a PC, streaming data systems that might need to use OPC. There's a variety of what we call universal technologies as well, as we found that many of these different types of instruments leverage a similar kind of connectivity strategy. And so using these portfolio connection technologies, we can plug into the infrastructure, and it gives us the ability then, and our customers, the ability to configure what we call orchestrations, which govern the flow of data, the business rules that determine what happens, right? So some examples might be, I'm in my LIMS system, I want to create a sequence and send it to Chromeleon. I can literally select a button inside of my LIMS. I might get prompted for a few pieces of information, and without ever having to open up Chromeleon, the sequence is created. And by the same token, I can pull the results back in. Or I can monitor whether a file is getting dropped in a folder, or mine files in a repository, extract information from those files, and mobilize that data to send it wherever it needs to go. Monitoring a bioreactor periodically during a bioprocess, and periodically when samples are taken, pinging the bioreactor for appropriate parameters, such as paddle speed, reactor temperature, etc. All of these are configurable workflows that our customers can manage and handle on their own. Now, this is an enterprise application. There are users, groups, and roles. Those are typically managed by IT professionals and laboratory managers. Again, the objective is that for the folks in the lab using technologies like SSO and those authentication functionalities, you want to know on whose behalf you're actually doing the automation. But for the folks in the laboratory, the goal is really not to create another application that they need to manage. It's to facilitate the flow of information across the endpoints that they've already got, and to give people the flexibility to exchange and bring in new data, to bring in new equipment, retire old equipment, and feel confident that they can establish the connectivity to mobilize data where they need to. The fundamentals of the Scitara Digital Lab Exchange are really pretty straightforward. We've talked about the connection portfolio, ranging from benchtop devices, instrument applications, informatics systems, even for manual operation. If you have a workflow that requires an individual to manually key in data, and there are still some of those around, it's possible to even create a form that can be triggered with a QR code, where the user might log in, enter in appropriate data, or get guided through a process. Then automation, right? Once the endpoints are all connected, what are the business rules that basically drive the flow of data back and forth across the different endpoints? And so there is an orchestration engine, if you will, that is fully configurable, that allows our customers to build out this business logic in a way that is straightforward and makes sense as a series of steps that they can very easily bring the different connected endpoints together, have a series of steps, be able to reshape and reformat data as needed so that by the time it winds up at its target destination or multiple target destinations, it can be in a form that is appropriate for that destination, whatever that format might be. And then on the monitoring side, as I said, for the folks in the lab, we truly do try to disappear. But for the IT professionals and lab managers, there are a variety of monitoring tools as well as configuration tools that allow people to observe the flow of information through the system, to be able to see all of your connected endpoints and their status, and effectively create an environment where you can actually watch in real time as data flows between all the different endpoints. So to wrap things up, if you think about the broader laboratory ecosystem, the Scitara role is really data mobility. As I said, we're a transaction engine, and we occupy on this screen really the bottom, shall we say, the bottom 3/4, right? Our goal is to connect the instruments and applications that sit in the laboratory with many of the applications that that you are using now that exist outside the laboratory in the cloud, bring those together as a single fundamental connected ecosystem, and perform what are fundamentally very transactional day in and day out tasks that would involve the exchange of data back and forth. But in the course of doing that, what we find is that we're actually liberating and mobilizing data, and we have access to a huge variety of really rich contextual data. For example, in the example I brought out before, when we pull data out of, let's say, a Chromeleon data system, we have access to all of the metadata around those results. We might want to send the results back to an eNotebook or a LIMS because that's what the LIMS wants. But we might want to package a richer set of data, including very specific metadata, perhaps combine that with other elements of the laboratory ecosystem, perhaps balance data or other related file data, and put a very rich payload together that would get sent to our customers' open application ecosystem, which could be their data lake of choice, where they can perform their data analytics as they see fit, knowing that the quality of the data in that data repository has rich context and is good quality. We've talked a lot about with our customers around what's the next generation of data archiving? What is that supposed to be? I happen to have the opportunity to be part of the team back in the late 1990s. I ran the product management team for New Genesis Technologies. We effectively created the SDMS platform. But do our customers today really want to recreate SDMS just using modern tools? So the definition of what is data archiving, what does it mean? And the ability to mobilize data at will gives us the opportunity to have these conversations with our customers around using modern technology, leveraging the cloud, leveraging the evolution of the applications and the informatics platforms in the laboratory. What is really needed to really advance the pace of science in the lab and advance the pace of drug discovery? So as an element of the ecosystem for data mobility, our goal really is to give our customers the power and the flexibility to mobilize data from or between whatever endpoints they choose, to be able to deploy it in a regulated environment that can be easily GXP validated, and to really accelerate the flow of information across whatever endpoints our common customers might have. With that, we'll wrap that up. We look forward to taking questions later on in the session. Thank you very much.
Fantastic. Thanks, Dave. Yeah, we'll take questions. We'll take questions at the end. I quite liked your term there around the did you say the data transfer engine or the data integration engine? I thought that was a good picture to paint of what's going on there. Thank you.